The astronauts read out
the gravitational effect of those planets.
Hi, I'm Matt. Welcome back to Mars Month on NASA Now.
The descent on Mars happens over such a short period of time that we actually don't have any fail-safes built in terms of being able to switch from one parachute to the next, or being able to turn one engine and turn one engine on and one engine off. You only have one chance to get this right.
There's much more of that ahead, but first, here's what's happening at NASA Now.
As Curiosity got ever closer to a place where no man has gone before, members of the Star Trek team lent their star power to set the stage for Curiosity's grand entrance. William Shatner, a pop culture icon, and Wil Wheaton, a successful actor and writer, both have a huge social media following. The two provided their own unique style on videos that were intended to reach far beyond a traditional space fan base. To see these videos, visit the NASA Explorer School's virtual campus.
Landing a spacecraft over 200 million kilometers away with a 7 to 14 minute delay in communications can create a real nail-biting situation, especially when you only have one chance to get it right. In June, we caught up with Dr. Anita Sengupta, a senior systems engineer for the Mars Science Laboratory Entry, Descent, and Landing System. Dr. Sengupta gave us a complete rundown of the amazing sequence of events needed for the successful landing of the Curiosity rover on the surface of Mars.
EDL, entry, descent, and landing, is the controlled process that allows you to get from really, really fast speeds just outside the atmosphere of a planet to incredibly slow speeds to enable a soft landing on the surface of a planet. You use EDL for landing on Earth, you use EDL for landing on the Moon, on landing on Mars, and then depending upon which planet you're going to, will slightly change the design of that system. The traditional terminal landing descent for the Mars exploration rovers and Mars Pathfinder rover was to use airbags, but those airbags can only handle a certain size rover. In this particular case, we actually had to use a system called the Sky Crane system because Curiosity is so big. This is going to be a groundbreaking, revolutionary approach to landing on Mars, and we're very excited. The entry, descent, and landing sequence has several different phases. The first one is when we initially interact with the Martian atmosphere. When we do that, we experience drag, which is this interaction with the atmosphere on the face of our entry vehicle, and that slows us down from hypersonic speeds, which is around 10,000 miles an hour, all the way down to supersonic speeds, which is 2 times the speed of sound, about 800 miles an hour. When we reach this supersonic speed of roughly 2 times the speed of an airplane, we pop a supersonic parachute. That supersonic parachute is about 60 feet in size, which if you think about it is about the length of 2 school buses. That supersonic parachute then slows us down to subsonic speeds, which is below the speed of sound, which is on the order of 200 miles an hour. Then we separate from our parachute and we start free fall. So the rover attached to a little spacecraft in the back starts to free fall towards the surface of Mars. Then it fires a total of 8 engines, which fire directly into the ground to help slow it down even further. We descend this way for about 4 miles above the surface till we get just about 60 feet above the surface. Then we start to lower our rover on a tether or a rope, and this maneuver is called the Sky Crane maneuver. We continue to descend towards the surface, and when Curiosity touches the ground at about just less than 1 mile an hour, we then separate from this vehicle above us by cutting that rope. That little spacecraft flies off to the side, and then Curiosity has landed, wheels down on the ground, and is ready to start its mission on Mars. A supersonic parachute is about 60 feet in diameter. It's the largest parachute we've ever built. We are deploying it or releasing it at the highest speed we've ever built, and we are having it experience the greatest amount of load, amount of force of any parachute ever has on Mars. The parachute is made out of a material called nylon and Kevlar. So nylon, you can think of it as the material that your backpack might be made out of, or that your tent might be made out of, and Kevlar is actually the material bulletproof vests are made out of. So the parachute is designed to be incredibly strong, but also incredibly lightweight. The parachute experiences a really interesting phenomena during its flight on Mars because it's deployed in this supersonic regime. This is 2 times the speed of sound. It actually tends to look like a jellyfish when it's flying down because it's sort of collapsing and reinflating. So Mars represents a really unique environment for our parachute to operate. The descent on Mars happens over such a short period of time that we actually don't have any fail-safes built in terms of being able to switch from one parachute to the next or being able to turn one engine on and one engine off. So we actually have only one way of getting to the ground. So for example, we have a single heat shield. That heat shield has to perform as intended. We have a single parachute. That parachute has to perform as intended. And we do have these 8 engines, and each one of those 8 engines has to perform as intended. Our entry, descent, and landing system is completely autonomous, which means that we're not communicating with it, we're not telling it how to do that. It has the brains on board, the computer on board to do that descent itself. So sometimes when you hear people talk about EDL, they talk about the 7 minutes of terror. And what this is because there's a large distance between the Earth and Mars, there is a delay time between when we can communicate back and forth with each other. And so that can be anywhere from about 7 to 14 minutes. And as a result, we actually don't know that rover has landed successfully on the surface until we've actually waited for that communication to come back to us. So after 7 years of building, designing, and testing our MSL EDL system, we've got only one chance to get it right. So we're looking forward to it, and we're confident we'll be successful.
We all know it was a huge success and a major accomplishment for Dr. Sengupta and her team. The Entry Descent Landing System. What an incredible series of precise processes happening at amazing rates of speed at vast distances. Here's a project where you can test your engineering design skills.
Teachers, we have a great assortment of activities for you and your students to expand your rocket science knowledge. Look for the Adventures in Rocket Science link located on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Visit our Facebook page and leave a comment. Be sure to join us for another special episode during Mars Month on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.